Alright, so number 1, match each equation below with the verbal description. Okay, look at A. This number out front is a vertical stretch. Okay, so it looks like it could be this one by a factor of 4. That's right. Translation of right 3, up 5, that is true. Remember, C is a lie. So this minus 3 is really plus 3 to the right. Alright. Let's skip down to C. Okay, for C, negative 4 means, that negative means it's going to be reflected over X. So that looks like number 4, reflect over X. Okay, and then it's right 3, down 5. Yeah, that's right. C is a liar, so right 3, down 5. Okay, so this one goes with that one. This one goes with that one. Alright. Now, these are in formats we haven't seen before, letter B and letter D. The one thing I'm going to look at is this plus 5 and this minus 5. Plus 5 means up 5. So that would be up 5. So that's going to go to this one. And then down 5, that goes to this one. Cool. Alright, describe the transformation of linear parent functions. Okay. Alright. So it's a flip over X. Okay, vertical compress. Okay. Now, if there was parentheses right there, that'd be a horizontal compress. Okay, and then that would be right 6, up 5. Okay, same thing here. If there's parentheses right there, that's a vertical stretch. It's a horizontal stretch because of the 1/3. That's 2 to the left. And that's 6 down. On number 4, domain and range. X-intercept, Y-intercept. Okay. And we're not doing any qualities. We're going to do the interval notation. The X-intercept right here is at 8, 0. The Y-intercept at 0, negative 4. The domain and range for a linear function is always negative infinity to positive infinity. Number 5, the x-intercept is looks like negative 6.5, comma 0. The y-intercept looks like negative 6.5, comma 0. The domain and range are negative infinity to positive infinity. Okay, domain, range, x-intercept, y-intercept. Okay, so x-intercept. Now, again, you can graph this and get the x-intercept and the y-intercept. Alright, so we're going to skip this. And we're going to describe the quadratic parent function. Oh, sorry, we are on 6. We're going to get the domain, range, and x-intercept. So for linear, domain and range are always negative to positive infinity. To get the x and y intercepts, we want to graph this. So menu 5.1, 0.7, and 2.330. So I got my y-intercept and my x-intercept. Alright, 7, again the domain, range, x-intercept. So let's plug this in. Menu 5.1, so 0.5 is the y-intercept, 1.670. Alright. Identify domain and range x-intercept, y-intercept of the description by the equation in the table. Okay, it's linear, so we're going to do menu 413 to get the equation. Okay, so negative 5x plus 15. So let's go graph that. Alright, so domain and range we know is always the same for linear. The x-intercept and the y-intercept, menu 5.1, so the y-intercept is 0.15, and then the x-intercept is 3.0. Alright. So about quadratic, domain, range, x-intercept, y-intercept. Okay. So the domain is always negative infinity to positive infinity for quadratic, but the range is from the y value, which is this, alright, so again, negative 4 is where it starts, because it goes from here up forever, right? So that's bracket negative 4, comma, infinity. And you can see on here the x-intercept is negative 5, comma 0, and 2, comma 0. There's two x-intercepts. And then there's a y-intercept right there, which is at 0, negative 3. Okay, can we take this table and, well, we have the equation. Alright, so the domain is always negative infinity to positive infinity. It goes left and right forever. But the range starts at 8, but since it was flipped over, it goes down forever to negative infinity up to 8. Okay, so it would help if we could graph that. -2 parentheses x minus 1 squared plus 8. So you see how it has a max and it's going down forever. It goes up to positive 8. Alright, it goes up here to 8. Alright, so let's figure out these x-intercepts. -1, 0, 3, 0. And then the y-intercept, you can see it right here. When x is 0, that's the y-intercept. But from the calculator, you can also see it's at 0, 6. And if you didn't know, you could just go over to it on your menu 5.1, 0, 6. Alright. Next. Describe what transformations. Okay. We're skipping this one. Okay, so if this is negative, if you look at any of the notes we've done, let's see here. Not that. Okay. Now, this also works for squared. That's what we're doing. So if this is negative, okay, negative a, that's reflect over x. 3 is greater than 1, so it's a vertical stretch. Okay. If there were parentheses here, that 2 would mean it's a horizontal compress. The -1 would be right 1, and then there's no d value, so it doesn't go anywhere else. Okay, 13, there it is. So you can see how it went right 1, and then it went down 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. Parent function x squared was reflected over the x-axis and translated 3 units left and 2 units down from y equals gx. So reflecting over x is when you have a negative a, so y equals -1. Okay, x. Translated 3 left, so that's a +3 squared. 2 units down, -2. Reflect over x, 3 to the left, and 2 down. That's it. Vertically compressed by 1/5, so vertical is out front, so 1/5. 1 to the right is -1 squared. 8 units up, +8. Vertically compressed by 1/5, 1 to the right, and then 8 up. What transformations happen to the cubic? Alright, now we're doing cubic. So, again, if there was parentheses here, that would be horizontal, compress, right 6, and then up 1. A negative out front is a reflect over x. Plus 2 means left 2, and it does not go up or down. And by the way, since 5 is greater than 1, that's a vertical stretch. Alright. Identify the domain range, x-intercept, y-intercept of the quadratic function. Okay. Let's write the domain and range in a set builder notation. We're not doing set builder. But domain and range, x, y, and then domain and range. Okay, so remember, domain and range for cubic is always negative to positive infinity. The x-intercept is right there at 4, so 0, 4. The y-intercept is right there at negative 8. And we could do the inflection point to negative 4. Alright. Again, domain and range are always negative infinity to positive infinity. X-intercept is negative 1, 0. Y-intercept is, I don't know, but we can figure it out by plugging it into the graph here. Negative 1 over 5 2x plus 5 cubed plus 6. Menu 5, 1. Y-intercept is 0. Negative 19. Wow. Using menu 5, 1. And then the inflection point is right there, but we don't need to write that down. Didn't ask for it. Okay, so find the key attributes, including domain range, relative minimum, relative maximum, x-intercept, y-intercept. So that's a lot. Wow. Yeah, so x plus 2, 4x minus 1, 2x plus 1. Let's do menu 5, 1. Let's go all the way to the left to get to this first thing we need. So the first 0 is negative 2, 0. And the next one, negative 0.50, and then 0.250. Let's get that y-intercept. There it says y-intercept. 0, negative 2. And like we already know, domain is negative infinity to positive infinity. The range is negative infinity to positive infinity. Okay, so the max, the local max. Okay, so let's go to the top of this hill over here. Negative 1.41, 7.13. And the minimum, so let's go to the bottom, negative 0.089, comma, negative 2.13. That was a lot. X, Y, domain, range, max, min. Wow. Alright, 21 has 3 different equations. Negative 2, 0, 0, negative 6, and then domain and range are the same for linear. Alright, so let's take this tab, go back up, square that. Negative 2, 0, that's the x-intercept, and the max. And then menu 5, 1, where is that y-intercept? 0, negative 12. And then the domain is always negative infinity to positive infinity, but the range goes down forever up to negative 12. So negative infinity up to negative 12, bracket. And then let's cube it. So tab, go back up. Let's caret 3 that. Alright, so we got our x, y-intercept. Domain is negative infinity to positive infinity, and then the range is negative infinity to positive infinity. Alright, last one is absolute value. Okay, what's the domain range, x-intercept, y-intercept? So your x-intercepts are negative 2, 0. The y-intercept is 1, 2, 3, 4, 5, 6, 7, 8, 0. The y-intercept right there is 0, negative 2. And remember, the domain goes forever negative infinity to positive infinity. That's a D. But the range goes down from negative 5 with a bracket up to infinity. Alright, and my vertex is at 3, negative 5. Alright. So just looking at this, you could graph it real quick. Remember, absolute value is book, enter. X minus 1 is inside the parentheses, and then plus 3 is outside the parentheses. So I got negative 1, 0, and 3, 0 for my x-intercepts. my y-intercept is, let's try menu 5, 1. 0, 1.5. And that would be at 1, 3 for my vertex. And that would mean my domain is negative infinity to positive infinity, of course, but my range is going down forever, so negative infinity, up to my vertex at 3 with the bracket. Alright, so I got vertex, y, and x, and domain and range. Alright. What's the vertex and the slope? Okay, we're not doing slope though. Transformations. Okay, so the vertex, again, let's just do transformations. 1/2 would be vertical compress. 4 would be a horizontal compress as well. Okay, so it'll be left 8, down 3. Alright, so this is a reflect over x because of that negative sign. Vertical stretch of 5. 7 right, and then 10 up. Okay, write the domain and range. Okay, domain, again, is negative infinity to positive infinity. But the range goes negative infinity down forever and up right here to 4. Vertex is what? Negative 2, 4. And that is a top, so it's max. Cool. Multiple choice. Yay, which equation can be represented by the graph? Okay. Alright, what is this slope? It should be positive. Can't be negative like that. It's on 12. Alright. Again, you can graph it, check the graph, what matches, okay? Which equation shows the quadratic function with vertex 5, negative 3. So remember, C is a lie, so it's going to look like a minus 5, and then a minus 3. So we're going to skip this one. Okay. Describing so we got this vertical compression. Okay, vertically compressed by a factor of 1/4, that's good. Vertically compressed by a factor, but not 4. Cool. And then 3 left, 2 down, that's correct. Absolute value, steepest graph. Now you could graph these to see 4, 6, 12. Pretty sure it's D. You can graph them and compare them. Which function has a range of negative infinity up to 2? So it would have to be having a negative out front to be flipped, so it can't be those. And then it goes up to positive 2, so that's C. You can graph those to check them. And that looks like it's it.